This is the 5th video about translations in transformational geometry. This one will focus on properties of corresponding sides of translated triangles. So we're going to start on page 6, number 13 at the very top. You're going to need a ruler or a straight edge. The directions say to translate triangle ABC up 3 units and to the left 6 units using a straight edge. So go ahead and pause the video right now, do that, and then return. But make sure you give this a shot. To remind you how this is done, I'm going to do A for you, but you're going to have to do B and C. All right? So let me go ahead and start at point A and go up 3 units, and then left 2, 4, 6 units. So that's where A prime would end up. So I'll put a point there and label that as A prime. B and C would be done in a similar way. So if you need to, pause before we continue. But you need to get that translated. So this is what it should look like when you translate triangle ABC up 3 units and left 6 units. This is our image here, triangle A prime, B prime, C prime. So I'm asking you to look at the corresponding sides, segments AB and segments AB prime. Now we already know they have the same length. What else appears to be true about those segments? Go ahead and pause and then complete 13A. There are 3 questions there about corresponding sides. The second question, 13A, what it seems to be true about segments BC and B prime, C prime, and CA and C prime, A prime. If you haven't finished that, do that now. It appears that each pair of corresponding sides are parallel to each other, seem to go in the same direction. And remember, if segments or lines are to be parallel, what must be true about their slopes? So go ahead and answer question 13B. Pause and complete that before you resume. So for 13B, if segments or lines are to be parallel, what must be true about their slopes? Their slopes must be the same value or they must be equal. Part 13C, you're asked to calculate the slopes of corresponding sides. I'd like you to find the slope of segment AB and the slope of segment A prime, B prime. So go ahead and pause and calculate the slopes just of those 2 segments for now. When you're finished, hit resume. All right, so we're going to go ahead and calculate these graphically. We'll do these 2 sides and leave the other 2 sides for you to do in case you've forgotten. So to calculate the slope, I'm going to go from B to A, left to right. So I'm going to start at point B, and it looks like we go down 2 units and left 1, 2, 3, 4, 5 units. So again, it looks like we go down 2, -2, and over +5. So the slope of this will be change in y over change in x, -2/5. Similarly, we're going to calculate the slope of A prime, B prime. So we will start at point B. It looks like we go down 2 units, and again, right 5 units. So the slope is -2 over -5. So it is the same value. So it turns out the slopes of these 2 corresponding sides are both -2/5. So please go ahead and finish 13C and find the slopes of segments BC and its corresponding side and CA and its corresponding side. Pause and resume when ready. To calculate the slopes for segment BC, it's down 8 over 8, and B prime, C prime, down 8 over 8, which is -1. Segment CA is down -6 over +3. It's corresponding, down -6 over +3, rise over runs, change in y over change in x, -2. So 13D, based on the results that we just did, is each pair of corresponding sides parallel? Go ahead and answer that question. And yes, each pair of corresponding sides is parallel. Their slopes are equal. So let's go ahead and look at this on TI-Nspire. All right, so here we're going to go to the templates, the menu, and then the templates, and we're going to look at slopes of sides. You'll notice it's giving me the slope of side AB, BC, and AC. So we'll go ahead and go up 3, as it just said in number 13, and go to the left 6. And translate using those directions, and notice that the slopes of the corresponding sides are equal. But again, as we've done before, let's grab points A, B, and C and see what happens here. So there we can see the slopes are equal there. A, we'll grab A. And we'll grab C. Again, what seems to be true about those? They do have corresponding slopes equal. Let's just do one more investigation here. I'm going to go onto the menu, click the I there, and I'm going to click on Connected Segments, and then Done. Get that 3D look here. But what seems to be true about the segment AA prime, BB prime, and CC prime? What seems to be true about those segments? What do you expect to be true then about their slopes? So let's go ahead and look at this. So we're going to look at this here, okay? What seems to be true about these segments here. Well, if you look at how we got there, down 3 to the right 6, the down 3, if we go from point C, would be here. To the right 6 from that would go here. And so the slope of this segment CC prime will be the change in y over the change in x, which is -3/6, which simplifies to -1/2. Similarly, for A to A prime, we would go down 3 over 6, and for B to B prime, down 3 and over 6. And to rectify or to verify that, let's go ahead and look at adding on in the menu the slopes of those sides and the resultant vector. And then I'll click Done. And so now when I hit Previous, it's showing the slopes of A and A prime, B and B prime, and C prime, and also the slope of the resultant vector. So watch what happens when I grab W and place it on C. Look where V goes. W on B, look where V goes. And on A, look where V goes. And so all 4 of those segments are parallel there. They have the same slope. And also one last thing is you can grab the end of the vector and pull it. And notice what it does. It changes the slide. But notice that those connected segments always have the same slope, even when it's undefined. So this concludes video 5.